All right, so what I want to discuss first is this proof theorems using similarity assignment. And then, if you haven't taken the quiz, I would like for you to spend some time on the quiz. And then if you have taken the quiz, we'll talk about that here in a moment. But if you've already done this assignment, then you're able to help us as we work through it. So let's talk about our prove theorems using similarity. If it will load, oh my gosh, I think Khan crashed, guys. This is going to be the only day that I planned to use Khan for the lesson, and it's going to crash. Ooh. Here, I had it open over here too. If this tries to reload the page, it may not work. So let's see what happens. So guys, this entire homework now is based around the midpoint theorem. So if you would like to take some notes, go ahead and jot down on your page. And if you haven't done this assignment, it is prove theorems using similarity. If you haven't done this assignment, I'm going to do it for you right now. So you should write some things down. If you haven't done prove theorems using similarity, please pay attention at least. So, in the following triangle, point E is the midpoint of AB, and point D is the midpoint of AC. So what we notate here are these congruent lengths. All of these four questions relate around our triangle midpoint theorem, which ends up proving that CB would then be parallel to DE. But right now, we don't know that. The other thing the triangle midpoint theorem proves is that triangle AED is half the size of triangle ABC. So we're going to start by proving that similarity ratio of that DE is half of CB. So in these assignments, when it says below is the proof that, what comes after that is the final thing in the proof, right? It is the thing that we are trying to prove. So I can't quite remember how much proof we did in Math 1. Some of you took it over the summer. Some of you had Mr. Hall, obviously. But when we were trying to prove something, that's always the last step. So as we work through here, the first thing we want to prove is that CA compared to DA is equal to 2. And guys, this seems mildly redundant, but I want to make sure that before we move into proofs, nobody feels like they're getting left behind. So if you already figured this out on your own, I know you might be like, okay, why are we going over this or whatever? But please have some patience. Everyone understands proofs at a different rate. So some of the things that we do in proofs strike, especially people like us, right? You guys are gifted because you've all been identified gifted. That's why you're in Math 2 as an 8th grader. Saying that CD is equal to DA because a midpoint cuts something in half feels silly, but we have to do it. Right? So the biggest thing to remember about proofs is if we want to use something later in the proof, like equal lengths, we have to have defined why we know it. So the first thing we do is literally define that a midpoint cuts something into two equal segments, right? CD and DA. We also then can say that CD and DA together make the bigger segment CA, and this feels unnecessary. And guys, why we're giving you scaffolded proofs right now, proofs that have a lot of it done, is later. Like here in the next month, I'll be asking you to fill in all of these on your own. Like there will be a drop-down menu on both sides, and it's what do we say now and what's the reason? What do we say now and by drop-down menu, I mean we're back in school, so we'll take a paper pencil test. I don't know why I said drop-down menu, but you'll be writing your own proofs. I like 2-column proofs much better than flowchart because it just feels more natural of I need to know this to be able to say this and get here. Right? Because what they say is the segment CA is made up of these two segments, and if I substitute from steps 1 and 2, this is also what I needed to explain to you guys. This means substitution from steps 1 and 2. So I'm substituting that CD actually equals DA. So I'm substituting that CD equals DA. And this lets us say, oh yeah, okay. So if CA is DA plus DA, then that division gets us 2. right? If something is equal to 2 of something, that division gets 2. Now is where we start to have to actually, not yet. All right, this one, we go all the way to the bottom before we have to pick anything. We do the same thing here with BA and EA. So we prove that the scale factor there is 2. Then, how are we allowed to prove similar triangles? All I've done is do 2 scale factors. What postulate can I use, or what theorem? Like side, 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 angle. Can't use angle, side, side. That's a bad one. What could so I proved that CD is equal to DA and that the whole length CA is double AD. I proved that the whole length AB is double AE. Especially if you've done this homework, this is where I'm looking for, like, okay, help us out. What else do we know? What else can we do? How can I prove similar triangles if I've proven this side is double the small side and this side is double the small side? What else do I need if I've got 2 sides? Another side or an angle. And actually the other side is what we're trying to prove. Right? So we know that we can't really use the other side because what we're trying to prove involves the other side. So the angle. We've got a shared angle. So when we're doing proofs, always look for the shared angle. We are then allowed to use side, angle, side. So because we've already related the 2 similarity ratios, that BA to EA is 2 and CA to DA is 2, because we've already proven both of those, we can now use side, angle, side, which then allows us to prove this by setting up CB to DE. Guys, before you even look at the drop down, go look at what is CB and DE. Oh, big triangle, little triangle. So I've got big to little. I need to set up big to little. Crap, which one of these is big to little? Well, CD is only part, so that's not right. CA to AD, right? So let me see if I have CA to AD. Yep, CA to DA. So then CB to DE, well, let's compare, well, it's CB to DE. Oh, yeah, that's 2, right? Because we said that's the same ratio, and that ratio that they had already was 2. And then multiply both sides of the equation. This is kind of like a trap door. How do we get rid of a DE on bottom? Put a DE on top. How do we put a 2 on bottom? Divide by it, right? Any questions on this one of proving that when we have connected midpoints, the base of the larger triangle is twice the base of the smaller triangle? What's up, man? I am done with these guys at 11:30. Unless you have gym next, can we meet at like 11:30ish or whatever? Or are you trying to tell me Khan Academy's broken?
No. You said you updated something on map and it hasn't been updated yet.
Come here. Because I know we're right at the deadline. What is the thing?
It was the Khan Academy, those dudes, January 3rd.
Here, take a step back. Let me go check your Khan Academy. That bamboo's a couple years old, too. No, that's the wrong class.
That's AJ's.
Oh, my bad.
Yes, mudslide.
I did that update.
Honestly, we disgusting, but also disgusting.
There.
Have you done mud runs before? That's just so awful.
Yep, looks like you took care of it.
Mud runs.
Alright, I will change that right now.
Okay.
Thanks, man. Alright, so on this one... Oh, I need to move on. My bad.
Why does yours make a nice dig? Mine doesn't make that.
What, the Khan Academy?
Yeah.
Maybe your sounds off?
I don't know.
No, it's a different dig. Mine makes a different dig from yours. That's why.
Probably because I did the fork in the garbage disposal. You know, the ring, ding, 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 ding. No? Okay. You kept saying ding, and that's all it made me think of was fork in the garbage disposal. Now, you've never heard the fork in the garbage
Well, I
disposal?
heard a story on Sunday. One of my field hockey people on my team said that she accidentally stuck a fork in the garbage disposal. Her friends swore. No, don't do that.
I don't know if it's appropriate.
You can't see it.
I know you can't. That's on purpose. I'm trying to see if it's appropriate or not. So at the end of class, maybe I'll show that to you guys. I don't know if I should record it and put it in my class video because it's just a silly dance. That's all it is. All right, so now they tell us EC to AE. EC to AE. Okay, so big to small, right? Bigger triangle to smaller triangle. DB to AD. Okay, so they're telling us we have similar triangles. Below is the proof that our lines end up parallel to each other. Now, if ED is parallel to CB, what are these angles? What do we call them? How do they compare to each other? Are they like complementary? Corresponding, right? Because they're in the same location. So, we work through this proof. And this all looks really complicated, because it's not. Here's the biggest thing that I wanted to make sure we talk about here. EC over AE is just a simple ratio that we build. Right? We can do anything we want in a proof, as long as we don't break any math rules. So EC over AE, we just build that. It's a given. They told us it's that, like, I could flip it, I could do whatever I want with it. We add 1 to both sides, so that then we can set up a side equal to itself, right? AE to AE would be 1. That common denominator allows us to put these together. We then can add the segments and say, well, okay, AC can really be replaced by AE plus EC. AB can really be replaced by AD and BD. And this, you guys are going to go do this on your own. So that's why I want to make sure like you go scroll back and forth to check these things. By the time we get down here, this also, I normally have to like negotiate with my Math 2 kids why you have to say something's equal to itself. Like often Math 2 students are like, this is dumb. Why do I say that? Guys, we just have to. It's one of those math things I don't really have a good explanation for. But if you're gonna say something's equal to itself, you have to actually say it. Because then we use this fact down here. Oh, crap, which one is it? Well, it's one of them involving angle, right? Well, AED, what would be the order? AED, what would be the other triangle order? ACB, right? And, well, we know a ratio. We talked about the sides. Is there any other angle referenced up here? No, it's all sides. So, if there's only one angle that's ever been referenced, can it be angle, angle? No. So we have side, angle, side as our similarity proof. Because, guys, up here, we proved the common ratios, and this is our comparison of big triangle to little triangle, right? AC to AE, big triangle to little triangle, big triangle to little triangle. So then, oh, that's it after this. So what would these angles be to each other? Corresponding. And guys, these are all proofs that we will then use later. Is now that we have proven this, quote unquote, now that we have proven this, we're allowed to say, oh, these two triangles are similar, using E and D as points on the triangles that are like keeping this ratio. We know angle 1 and angle 2 will be congruent. Well, we also know that because they're similar triangles, right? Corresponding parts of similar triangles must be similar. Really, I'd like to have you guys pull out your computers and work on this and let me know if you have questions. Because I know I can do it for you / with you, but that's, yeah. Give me a second to see if I can load the page I wanted to. So go ahead and pull out your computer, because if you've already done that assignment, I want you to work on the quiz. And if you've already done that assignment, I have a new assignment for you. Sigh. Huh? Oh, there's a couple people that are done. Crap. Khan says we've identified a technical issue and are working to fix it.
Yes!
So I don't know if you'll be able to get on or not. You might be able to get on, though.
So how did you make your legs bigger?
Give me a second. I can't get distracted right now. Just give me just a second. First off, you have to know what random crap you have in your basement. That's...
I collect random crap. Well, I use it because softballs for cars.
All right, if you are all caught up with your con work up to this point, like everything that I had assigned, it's now time to work on your unit test. So if this goes through, yeah, I wanted to give you some class time. Why are you covering up your eyes?
Because we don't want to do it. Yeah, we don't want to.
Guys, you're ready. It's only 9 questions.
We don't want to do.
Oh, okay, I see.
It's so annoying.
All right, so if you have any questions on proof theorems using similarity, I'm keeping this pulled up so we can continue to talk about it. But that one, you guys all had the same questions on. Like, the same 4 questions go to each of you. In the quiz 3, you had different questions. So if you have a question on that, I might need to help you on that. And on the unit test, I believe we all have the same. No, I think we have different questions, actually. It's at least randomized order. This will probably be the last test we take in con for a while, but we've been working straight through the con stuff, and I like this unit test. The other thing is to print. To print a test like this uses a ton of paper because the amount of triangles I would need to show you. Not a legitimate ton of paper, but...
I'm sorry, I can't do this. I'm mad at con right now.
well,
I got 100% on something, but now it's showing up as 75%. Well, and I don't want to redo it. It's actually that.
Alright, so those of you at home, if you're watching this video, your unit test should be assigned to you now. Go put some work in on that.